Hey everyone, thanks for joining me. I'm Scott Sumner at Kadiska, where we build solutions to help you deliver an amazing digital experience to your customers and employees. And today we're going to talk about migrating your PBX to a cloud PBX and seeing what kind of performance impact they may have for you. So we'll take a few quick look at the kind of things that are going to impact that kind of migration to a SaaS-based cloud PBX. And we're also going to take a look at the performance drivers and how the network has to support those. So just a quick overview of that. I'm going to go back and give you guys a crash course in the MOS score, so mean opinion score for voice over IP. I know you guys probably already know this already, but it's just worth revisiting before we go and look at some live data live in the internet. So what defines a good call on voice over IP? It's really the MOS score. MOS score is a factor that's perceptive, it's qualitative. Basically, you want to have a MOS score above 4 to have a good quality call. And as it starts to drop, then you start to have dropouts in the conversation and start getting garbled speech or delay. So it's a good measure of whether or not your phone calls are going to sound good on voice over IP. And you can see here two of the key major influences of that. First, one-way latency, so the delay between you and the other person you're talking to, no matter what you're going through in between you and that other person, if it's going through the PBX, of course, but other network segments, VPNs, firewall, SD-WAN, whatever's in between you and the person you're talking to, the latency is really important. So you can see around 75 milliseconds in one-way delay, you're starting to get a drop that's important, and you can start having some issues understanding the person, depending on the codec that you're using for that, of course. Also, packet loss, very, very important. It's almost intolerant to packet loss when you're using voice over IP for two reasons. One is that dropping things out on a UDP transmission of packets means you're going to lose chunks and segments of speech. And the other one is that you might just lose the call completely. So anywhere between 1% and 5%, you're going to see calls dropping. So you don't want to see that kind of percentage of packet loss in your stream or your conversation. So that's really the basics of the MOS score. And what's interesting about packet loss and latency is that these things actually happen at the same time. So if you have a little bit of latency and a little bit of packet loss, you could get a perfect storm together, and your call and MOS score are going to drop accordingly. So we want to take a look at those two as well. What's the best practice? What are you trying to aim for when you're delivering good voice over IP services? Latency, as we saw, target around 50 milliseconds is where people don't perceive any issues with a call. When you get to around 150 milliseconds in round trip, you're starting to really hear people talking over each other, maybe some echo. Packet loss, we talked about that. So 1.5% is a point where you're starting to see call drops and call quality issues. And also there's jitter or delay variation, which is very similar to latency, but it's the variation between the receipt of packets, also a factor. But in voice over IP, there's jitter buffers and echo cancelers and different technologies that make that less important today than packet loss and latency. So these are the factors to think about when you're migrating your PBX from sort of local on-premise to a cloud location. You got to make sure that the calls still retain those kind of quality metrics. Let's take a look here before we go live and look at some data. What has changed? So this is what you probably have now if you're migrating to a new cloud voice over IP platform. You have your PBX here, your public branch exchange running in a data center or in your headquarters or somewhere where people are going to be connecting to it, say it's from a retail location or from a work from home employee, they're connecting into this private network. So if this call is not going out to somebody outside your company, it's all internal to you. This is what it might look like. If you're calling out to somebody in a different city or in another company or an individual, the PBX would then shoot the call out into the public exchange. And this is fairly straightforward if you want to keep your latency and your packet loss low in this kind of simple environment. But as you move to the cloud, this PBX disappears and it's being hosted up here somewhere out in outer space. Well, maybe not really, but actually the cloud, as you know, isn't always just one location. And what you'll see with a cloud PBX is that often they're hosted in a variety of locations to be closer to the users or to be regionally low latency for that purpose. But when you're connecting into it from work from home, you might be going through something like a secure edge device, like a CASB security appliance or some other secure cloud gateway that might direct you to a particular cloud PBX, also your DNS resolution and the different locations you're at will be a factor in determining which of these cloud locations you're going to end up talking to. And of course, the conversation that you're creating has to go through these PBXs. So if there's people in different locations, different countries, they're likely going to be going through multiple of these cloud instances, which can introduce latency overall. So this is just a quick view of what it looks like when you're moving to a cloud PBX. Now I want to show you specifically, if we take some examples, what it would actually look like in terms of achieving latency to those different locations. This is what you would do before you migrate to a cloud PBX. You want to make sure that all the locations you have in the world where you'll be accessing from company sites, remote employees, branch offices, manufacturing locations, that they're all able to really reach these cloud PBX as well. But also to get to people that you want to talk to. So if you have a lot of your customers are in India, for example, you better make sure that you have a good latency to them as well. So it's important to be able to look through all this. So what we're seeing here, the Kadiska network tracing application that can tell us what the performance is to reaching any specific website or SaaS application from all these different locations around the world. And for our case here, what we're going to do is we're going to look for a specific target, and that target is going to be the Avaya Cloud Platform. It's one of the most common ones that you would see out there. So I'll just filter down on that, and you can see for our particular company, we have about 10 locations that we're really interested in seeing how well we can access that platform. And now if you look carefully over here, in North America, you can see that, for example, not a really good start for the guys in San Jose. They're 110 milliseconds away from the Avaya Cloud server. That's bad, right? Because we're already past the 75 milliseconds you would need to have a successful call, and the packet loss is already above 1.5%. So just starting here, we know that this probably isn't going to be a very productive conversation. Other areas in the States doing much better. If we look across the globe, it looks like actually, strangely, San Jose might be one of the worst places. Unfortunately for us at Kadiska, we have offices in Paris and the US, so the performance in France is also going to matter. And depends on who's talking to who, but you can have a pretty bad day if these things don't work out too good. So why don't we look and see what's happening here in San Jose? I'm interested in having a call with some people in Helsinki and, let's say, Toronto. So let's take a look and see how those three can reach the Avaya Cloud Platform. So I'm just going to take Toronto, Helsinki, San Jose, and then I'm going to do a path performance trace, and we're going to take a look over today how it is that we can reach that platform. So you can see here immediately on the loss over time side, there are some pretty bad packet loss events happening here. So we're looking at like 33% when you're from San Jose trying to reach the Avaya Cloud Platform. You can also see from the round trip that if you're in Toronto or Helsinki, is almost no latency at all. It's really working super well, but for some reason, San Jose, it's flipping between like 75 milliseconds and 150. And what we're seeing with this step increase in latency is really a change in the path. So the network path is changing, and that's why there's a resulting increase in latency. So if we just took a quick look before we look at the what's going on with that particular site in San Jose, you can see how each of these offices is connecting directly to the Avaya Cloud Platform. So from Toronto, it's connecting to a platform over here, and this one's actually in AWS in Canada. So it makes sense. You're in Canada, you're connecting to a cloud platform here, the Avaya Cloud office here in Toronto. If you're in Helsinki, you're connecting to one that's basically in Finland as well, right? So this is good news. No, it's not good news. You're going across from Helsinki into the UK, and then you're actually going across the ocean to Amazon AWS, where they're hosting the cloud office at Avaya. Unfortunately, that's located in the East Coast US in Ashburn's data center. So that's a long way to go for a call. And San Jose also, let's see where they're going here. So there's a lot of network routes that they're going through. They're hopping into the network. If you're in our San Jose type office, you'd be going through Telia in the US. And then over here, you're ending up at AWS hosting in France. not good. So if you want to have a phone call and there's actually a server in Eastern US, you're actually going to France for that server, that might explain where the latency came from. Let's take a look a little bit more, because you can see, depending on the time of day, San Jose is flipping between the cloud office via platform in France and the US, so that we can take a look at that and see what impact that has on loss and latency. So if we go up here, let's just highlight delay across these different platforms. And what you'll see here is that there's certain links in San Jose that are really causing significant latency. So in the backbone here between the US, Ontario, New York State, and then goes overseas to the UK, you're seeing like 140 milliseconds basically in here. And when the route stays more domestic, you see there's very little latency here, but there still is a problem between the US and San Jose and the East Coast. So there's some sort of traffic loop going on here with Telia, and you'd want to talk to them about that if that was your only provider to that region, or maybe you'd want to choose to use a different internet or service provider to make sure you didn't have that kind of delay going to the cloud office. We can also look at the loss to see if there's any significant loss in these links. And you can see here that on the route going to if they're connecting into the French AWS site where they're hosting the cloud office, basically there's a 22% packet loss happening here in the AWS cloud network, which will definitely be dropping all your calls. So hopefully you're not talking to somebody really important at that moment in time. And you can see how this changes around. So if I'm in the low latency route that's going across to America, very small packet loss. We're hitting the platform in the East Coast. That's working well. But you see when there's a route change on the internet and you're forced over to France for some reason, Telia has decided to do that because they have a better route, or it's lower cost to them, or something like the cloud office is asking them to load balance to another location. That's when the loss is going to show up. And every time you go through this particular network path, you're going to have a digital experience that really falls well below your expectations. So if you're troubleshooting this, or if you're thinking of migrating to the Avaya Cloud Platform or any other cloud IP PBX, you're going to want to trace your network performance to all these locations beforehand. You want to make sure that the routes are stable, that you have good peering partners, and that the latency and loss to each of those locations is going to give you a really good MOS score and a really good experience calling people. And you can do this all around the world. We can set this up for you in less than a minute, and you can easily do a quick assessment to make sure that your migration is going to be successful. So that's what I wanted to show you today. A lot of great tools on Kadiska.com that you can learn about. And if you have any issues migrating to IP PBX or any SaaS application, just let us know and be happy to help you out. Thanks for joining me today.